Hello everyone. Today we are going to see about prototype design pattern. So this prototype design patterns comes under creational design pattern category. So we have three type of design pattern: creation, behavior, and structural. So this comes under creation design pattern. So it deals with object creation. So problem. So first we will see what is the problem we are having and how it resolves. So the problem is, so for example, take an example of Amazon application. Okay, so in Amazon application we are going to search for some laptop. So consider we have selected one HP laptop and we have added to the cart. Okay, so this is one scenario. So uh, once we have added, then we will move to payment page. So there we can add another one also by just clicking plus. Below the order we will have plus. Okay, so that time we can add how many laptop we want. It's like if we add plus plus plus, then it will be added, same object will be added. So consider that the laptop is product under, so Amazon application under cart I have added one HP laptop and I have to add two more. I don't need to go to this under search for HP laptop. I just click on the plus button so that the same object will be added into the cart. Am I right? So there, consider in search page we actually create the actual laptop, but once we reach the another module, like we are in payment page, that the application is in a different module. So there we don't know what is the object and how to create the object. We are just clicking plus. So there, using the existing object we need to create the object, the another object of the same property and same object we need to create. So there we don't know what is the actual object. So using the same object we need to create another object. So what we can do, so how to create same object? Using copy constructor. We will use copy constructor and we will create the same. Okay, but here the responsibility of creating the object comes to the different module, but we are creating using that product itself. So now the uh, we can design such a way that that object itself have the responsibility of creating that object and returning that object from its own. Okay, so that is for an example. And another example is, we have ordered something and we have ordered 1 month ago, and again we are opening the Amazon application. Okay, so now we need to repeat the same order. So what we need to do, so consider last month we have ordered 5 products in one order. Okay, one laptop, one charger, one mobile phone, like that 5 products we have added, but the same order we need to place it again. What we will do we search that in Amazon page and one by one do we add in cart? No, there is an option like repeat order. Am I right? Repeat order is that. So if we click on repeat order, same cart will be created. Okay, the cart will be added with the same products. Okay, whatever we have created in the same in the last month order. So then also we will use prototype design pattern. So whatever order that is present, using that object we will create another object of the same properties present inside it. So then also we can use prototype design pattern instead of that module creating each product and adding into or a cart. Instead of that, it will actually it will create another order object with same products. So that object itself should be responsible for creating another object. So that is like prototype design pattern. So this is one example scenario for prototype design pattern. and instead of so here the problem it will solve is, instead of creating the object instead of v, so instead of client code creating the object, what we can do is, using the existing object itself, we will try to create the object and providing the responsibility of creation to that object itself. So in this statement, what I'm trying to say is, instead of client code creating that object, okay, instead of client code creating the object, using the existing object itself, we will try to create the object and providing the responsibility of creation of the creation, responsibility of creation to that object itself. Okay, so this is uh, prototype design pattern. Okay, and another example is, if we have game and it will have some characters. So example, take Clash of Clans. So there we need to create during war we need to we can release dragon in the war base. So if we click keep on touching the screen, those many dragons will be released. So that is, instead of creating a dragon one by one, we can clone it. Like using prototype design pattern, we can copy the same object and can deploy it. So there also we can use prototype design pattern. So like this. So whenever we need to create the same object again and again, we can use prototype design pattern. And instead of client code creating that object, the responsibility will be given to the object itself. So here the object itself is responsible for creating the object and returning it. So how can we implement this? Okay, this is the problem statement and this is what it is going to solve. But how can we implement that? So what we can do is, so we are having a product class, okay, and I'm going to create an interface which is prototype object, okay, and here I'm going to have function and it will return prototype object, prototype object pointer, and this function I am naming it as clone, okay, and in this product is going to implement this I prototype object, and inside this clone object, clone function, what I will do is I will write the, I will call, I'm going to call copy constructor of product class, okay, and return pointer, I'm going to return I prototype pointer, a prototype pointer by calling the copy constructor of product class. Okay, so this is how I'm going to implement this. So I'm going to create an interface of prototype class. It is going to have clone function, and whichever class is implementing this iPrototype class, it need to implement this clone function. Inside this clone function, I will be returning the iPrototype pointer by calling the copy constructor of its own class. So this is how I am going to implement it. So another example is, if we have a website and we need to create all buttons in the same dimension, same design, means we can create a button object of certain properties, and using this prototype design pattern. Whenever we need to create another button means we can use this clone function. We can inherit this iPrototype class, and we can create this clone. We can define this clone function, and we can create the same button again and again. So that also we can use. So I'm going to show you a code example for this. So here if you see, I'm having iProduct prototype. So this is having clone pure virtual function, display pure virtual function, and default destructor. Okay, so this is interface for prototype. So whichever class is implementing this prototype interface, it needs to implement its own clone function. So inside this clone function, if you see, it is returning iProd prototype pointer, and here if you see, it is calling product of star this. So this is nothing but to call the copy constructor of its own class. Okay. So if you see product is having two properties, string name and int price. So using parameterized constructor, it will be constructed, and once we need to create another object of same properties means we can just call the clone function, and it will return the iProduct prototype pointer with by calling the copy constructor, and here copy constructor it will construct the same object properties. So this is about product class, and I am going to create order. I am creating order class also. It will has a list of products. Okay, so this is also implementing this prototype class. So this will also have the clone function, and it is also returning iPrototype pointer, and it is calling the copy constructor of order class. So inside main function, if you see, I am creating two products. One product is laptop and another is charger. So I am creating using parameterized constructors. Okay. So another two object I am creating. That laptop I am cloning. Two times I am cloning and storing in laptop product 1 or laptop product 2. But it is of type, if you see, it is of type iProd prototype pointer. So in C++ we have dynamic cast. So as you all know, we have dynamic cast. So since this product is inherited from iProd prototype, we can use dynamic cast to traverse the inheritance hierarchy. So from iProd prototype to product, we can dynamically cast it. So I'm the product O here. So which is casted from iProd prototype interface. Okay, so I can display it, both I can display it. It will print, like display will print the name and price. Okay, and I am creating another order object. So this order object, I am going to, after some days I am going to return the repeat the same order. So what I am going to do is I am going to call the clone function of that order, and it will return prototype object pointer. Okay, and finally I can dynamically cast it to order a class. So here I will have the object like pointer, which is order, which is of type order. And finally I'm deleting all the pointers. So this is for avoiding memory leak. So this is about prototype design pattern. So prototype design pattern is nothing but uh, so what it will do is, if we use copy constructor directly means it will does the compile time call. But if we use this prototype design pattern, it will use the runtime to bind the function. The clone function will be bind during runtime only. So as we have used virtual function, so if we call the clone using reference or pointer, then during runtime the proper clone function will be called, and the same object will be created. So this is about prototype design pattern. Thank you guys.